Now let's try to solve the problem number 58 of your textbook. So once again, this is a pendulum problem. So you will find that the approach and the result will be almost same. Now let's see a simple pendulum of length L. So a pendulum of length L, right? Having a bob of mass M. So mass M is deflected from its rest position by an angle theta. So it is deflected by an angle theta and released. The string hits the peg, which is fixed at a distance x below the point of suspension. That means from the point of suspension O below here, there is a peg on the wall or something, right? Then show that the suspension and the bob starts going in a circle centered at the peg. Of course, what will happen when the pendulum will come here? Pendulum will come here, and then pendulum will take a circle around this peg, around this peg. Take a circle around this peg, right? Like say, pendulum may be here, or maybe here, or the pendulum may be here, something like this. Now the question is, assuming initially that the bob has a height lower than the peg, so that the maximum height reached by the peg equals to its initial height. This is, of course, you don't need any mathematics for to answer that it is yes, because here the initial potential energy of the ball is mgh, where h is where this is h. And final potential energy of the ball also will be h. Also will be h because it has no other energy. So we can just write a line here. Since the real potential energy is equal to final potential energy, the bob, the bob's final height, final height, will has to be equal to its initial height. So this is part A. Part B onward is difficult. What part B says? Part B there, say the pendulum is released with an angle 90 degree and x equal to L by 2. That means the peg is just half the distance of length L. Then find the maximum height reached by the bob. Now the method to find the maximum height reached by the bob, etc., we have done also already in last 2-3 examples. Maximum height reached by the bob from its lowest position before the string becomes slack. This kind of a problem we have already solved. So go by the same method. Let's draw a diagram here. Say this is the point of suspension and this is the and the bob is taken, released from here. The theta is 90 degree and x is L by 2. So this height is also L by 2. This height is also L by 2. Then bob will take a circle like this. If the bob goes by the whole circle, bob will take a circle like this. Now, this point is already marked O. Let us say this point, we have to give some name. Let us say this point is C, and let us say this point is P. I have to start from here. What is the energy of the bob here? Energy of the bob here at P is just equal to kinetic energy of the bob here at C potential energy of the bob at C converted to its kinetic energy at P. Just like this, right? So we say, what is the potential energy at C is equal to potential energy at C is equal to mgl, right? At C equal to mgl, so this total height is L. So kinetic energy at C is also equal to mgl. It cannot be different than this. Now let us say the bob stops rotating here. Bob stops rotating here at an angle theta with the vertical. The same kind of a problem. Now, kinetic energy, this is kinetic energy at T. I'm sorry. Potential energy at C is equal to mgl. The same amount of energy is converted to kinetic energy at T. Right? Now, let us say at this point, its tangential velocity is v1. Tangential velocity is v1. If so, then, and we have seen the technique, the same technique earlier. This is mg, and the force in this direction is mg cos theta, mg cos theta. We have to apply the same technique as earlier. Therefore, radial force cos theta, mg cos theta will be equal to the centripetal force m v1 square divided by L upon 2, because this radius is L by 2. This radius is L by 2. This is equal to 2m v1 square by L. So from here we get 1 square is equal to v1 square. This m and m will get cancelled. M and m will get cancelled. Is v1 square is equal to 2gl. v1 square will be g into L divided by 2. So gl cos theta by 2. This is v1 square, right? Now, we have to find out the potential energy at the point. Have you given any name of this point? Let us say this point is named P. Let's say this point is named P. Then potential energy at E, right? Potential energy at E. U at E potential energy at E is equal to mg mg then h. What is h? h is L by 2 plus L by 2 cos theta, right? So this is L by 2 plus L by 2 theta. This is potential energy at E. This is equal to, we can write m g L by 2 1 plus cos theta. Mg L by 2 1 plus. Now let us write a line for your memory, so that you remember the process later on. We write here that kinetic energy at point P ties to the kinetic energy at point E plus the potential energy at point E. This is simple. Potential energy at E plus kinetic energy at E will be equal to the kinetic, because there is no other source of energy. From here we get kinetic energy at P was mgl, that we have already found earlier. M kinetic energy at P is mg, right? Say here I have done a mistake. This is not mg. Kinetic energy at P is not mgl by 2, but kinetic energy of P is equal to L. The potential energy at C, the same kinetic energy it was holding at P. This is mgl. So kinetic energy at P is mgl. This is equal to kinetic energy at E. Kinetic energy at E is equal to half of m into v square, v1 square. v1 square we have already got here. This is the v1 square. So half m into gl by 2 cos theta plus potential energy at E is mgl by 2, mgl by 2, 1 plus cos theta. Now, here we have only cos theta and mgl, all mgls gets cancelled. So I'll not really waste time to make this field calculation. If you calculate, you will find that cos theta is equal to 2 by 3. Cos theta equal to 2 by 3. Let's write it here. From here, we get cos theta is equal to 2 by 3. If that is so, what is the maximum height? Therefore, so maximum height is equal to L by 2, 1 plus cos theta. If you calculate, cos theta is equal to 2 by 3 already got. So if you calculate, you will find it is 5L by 6. That is the answer of part B. Answer was find the maximum height reached by the bob above its lowest position before the string becomes slack. This maximum height is 5L by 6. And that is the part 3 of this question, for which I'll just take this board up and make some space for it, like this. Okay. Part 3 of the question says, find the maximum value of x by L. That means how big x can be. That means how downwards x can come so that the bob makes a complete circle. Here we have found, if here we find that x by L is half. X by L is half, but the bob did not make a complete circle. Question says there is a position here, there is a position here where if the bob is little lower, then the bob will make a complete circle. The bob will make a complete circle. Starting from here, the bob will come down to this point, and then it will make a complete circle like this. What is this value? If this is x as usual, and the whole length is L as usual, then what is the maximum value of x by L? That is, they want us to find it, right? Here, actually, we go by the same method, and the value of x will be found. Let us say this point is C. Let us say this point is C. Its name is C. Then centripetal force here is only mg, nothing more. And what is its centripetal force is provided by the gravitational force mg. And if here its velocity is v2, then measure of centripetal force is mv2 square by L by mv2 square divided by L minus x. Because this is whole thing is L, this much is x, so this is L minus x. So in third condition, that means in question C, if this highest point is also marked as C, here we find the tangential velocity at the highest point. The highest point is equal to v2. Then m v2 square divided by L minus x. Because mind it, now the radius of rotation is only L minus x. This has to be equal to mg. From here we find that m v2 square is equal to mg into L minus x. Right? From here we get v2 square is equal to g into L minus x. Like earlier, we have to find out here also, you have seen that we have found out V1 square. Then we found out the total energy equation. We go, it is the same method, absolutely the same method, right? So we got mv2 square. Now, the earlier also, after finding out V2, V1, we calculated its uh, kinetic energy. Here also we calculate the kinetic energy. So kinetic energy at C is equal to half m V2 square is equal to half m. This square is g into L minus x. This is equal to mg L minus x whole divided by, and we take the board a little out and go further. Once again, the potential energy equations. Potential energy at A, when it started. Potential energy at A, when it started, was mgl. When it started at the left-hand end, when it started at the left-hand end, if you have forgotten, this is the point which was, this was the point which was A. This was the point A. When it started, its potential energy was mgl. And what is the potential energy at C? This is done. Potential energy A is done. And potential energy at C is equal to mg. And what is the total height now? So what is the height from here to here? Is 2L minus x. 2L minus x. So mg 2L minus x. Right? And this is equal to, we split it out, 2mg minus 2mg x. 2mgl minus 2mgx. And what is the kinetic energy at C? We go, look, we're going by the same method. Kinetic energy at C is, will be, kinetic energy at C will be the potential energy which was available. Kinetic energy at C is half mv square. This was the kinetic, this was the kinetic energy, this was the V2 square. So kinetic energy at C is half m V2 square is equal to half m, and V2 square was, V2 square was given by this equation. Half m into g into L minus x. This is equal to mg by 2L minus x. Oh, we did it already once. Kinetic energy at C was like this. So now potential energy at A. Now our approach will be potential energy at A will be potential energy at C plus kinetic energy at C. And potential energy at C is at A is mgl, that we have written here. So mgl will be equal to potential energy at C, we have already written 2 mgl minus 2 mgx, 2 mgl minus 2 mgx plus kinetic energy at C is mg by mgl by 2 mgl by 2 minus mgx by 2. If you just simplify this equation, you will find that x is equal to 3L by 5. And that will be answer of the last part. That means if this is our bob, and the whole thing is L, the x is 3/5 of L. That means x should be somewhere here, 3/5 of it. Then the bob will take a complex circle, right? So this is how we solve this problem. Then we shall come to the next problem after a few minutes.